zeroth law of thermodynamics and temperature. Now, before talking about zeroth law of thermodynamics and temperature, we will see what is defined as thermal equilibrium. Thermal equilibrium is when there is no heat transfer between two objects when they are connected by a thermally permeable path. So that is when two objects are said to be in thermal equilibrium. There is a path, there is a way where heat can flow in between, it can transfer in between, yet there is no heat transfer. Then two objects are said to be in thermal equilibrium. In such situation where two objects are in thermal equilibrium, they are then called in same temperature. So therefore, it implies that temperature is a measure of ability to flow of heat. Now, then if we look at what is the zeroth law of thermodynamics, formally the zeroth law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with a third one, then they are in thermal equilibrium with each other. That means, in simple terms, if there are two systems, A and B, and they are individually in thermal equilibrium with another third system, C, A and C is in thermal equilibrium, B and C are also in thermal equilibrium, then A and B are also in thermal equilibrium. That is what mentioned in zeroth law of thermodynamics. This is a very straightforward law. This is a transitive relationship. That is, it can be extended to more systems than 3. Now, having known what is called the temperature, now we should look at how to measure temperature. In measuring temperatures, thermometric properties come into picture. Thermometric property is a property of a material which changes with the temperature. So any physical property that changes with temperature is called a thermometric property. For example, volume, resistance, pressure, etc. are examples of thermometric properties. Now, if we take mass of an object never changes with temperature. Therefore, it is not a thermometric property. However, just being able to change with temperature is not sufficient to be a good thermometric property. Some other preferred features are there. When we use a thermometric property for measuring the temperature, we use two fixed points in developing a thermometric scale. That is a lower fixed point and higher fixed point. Now let's see how can we develop a thermometric scale using lower fixed point and higher fixed point. As shown in this figure, the lower fixed point temperature is theta L. The relevant value of thermometric property is XL. The higher fixed point temperature is theta H. Relevant value of thermometric property is XH. The unknown temperature is theta, the value of thermometric property at unknown temperature is x. Then we can write this expression. It leads to this expression for the unknown temperature theta in terms of values of thermometric property and temperature values of lower fixed point and higher fixed point. In Celsius scale, lower fixed point is the ice point of water. It is assigned 0 degrees of Celsius. Higher fixed point is boiling point of water. It has been assigned 100 degrees of Celsius. Therefore, if we modify this expression for Celsius scale, we have the expression as follows. This is the expression for Celsius scale. Absolute scale or thermodynamic scale. Now, before talking about absolute scale or the thermodynamic scale, let's see what is defined as absolute zero temperature. Absolute zero is the lowest possible temperature where nothing could be cold and no heat energy remains in a substance. So it is really absolute zero is a practically not achievable temperature. By international agreement, absolute zero is defined as precisely 0 Kelvin on the Kelvin scale, which is absolute thermodynamic temperature scale, and minus 273.15 degrees of Celsius on the Celsius scale. In other words, 0 Kelvin is equal to minus 273.15 degrees of Celsius. Or vice versa, we can say 0 degrees of Celsius equals 273.15 Kelvin. In defining absolute temperature scale, no lower fixed point and higher fixed point is used, but only a single fixed point is used. The single fixed point used in defining, in preparing absolute temperature scale is the triple point of water. Triple point of a substance is the temperature and pressure at which any substance can exist in equilibrium in the liquid, solid and gaseous states. So therefore, triple point of water is also the temperature at which the water can exist in all three phases of solid, liquid and vapor. The triple point the triple point of pure water is at 0.01 degrees of Celsius. That is 273.16 Kelvin. That value, that temperature is used to calibrate thermometers. If we write an expression for absolute temperature based on triple point of water, it will be like this, where T is the absolute temperature, Xt is the value of thermometric property at that temperature, Xtr is the thermometric, the triple point of the thermometric material into 273.16. The relationship between Celsius scale and absolute scale temperature, as I mentioned earlier also, is like this. Now, if we look at commonly used types of thermometers, mercury in glass thermometer is one of the commonly used thermometers. If we look at the characteristics of mercury in glass thermometer, it is clearly visible with light silvery color. The temperature range that it can measure falls between minus 37 degrees of Celsius and 356 degrees of Celsius. Minus 37 degrees of Celsius is the freezing point of mercury. 356 degrees of Celsius is the boiling point of. Another type of thermometers which is analytical to, which can be compared to mercury in glass thermometer is alcohol in glass thermometers. And now let's see what are the characteristics of alcohol in glass thermometer. Now if we look at the characteristics of alcohol in glass thermometer, since alcohol is colorless, it has to be dyed, which has to give a bright color. The alcohol in glass thermometer generally contains ethanol, toluene, kerosene, or other liquid mixture, depending on the manufacturer and range of temperature to be measured. The temperature range it can measure falls between minus 112 degrees of Celsius and 78 degrees of Celsius, where minus 112 degrees of Celsius is the freezing point of alcohol and 78 degrees of Celsius is the boiling point of alcohol. Now let's see advantages of mercury in glass thermometer compared to alcohol in glass thermometer. Since mercury is a good conductor, it shows fast reactions. Mercury shows a uniform expansion behavior better than alcohol. Mercury in glass thermometers are more durable because mercury does not evaporate easily. Mercury in glass thermometer is smaller than alcohol in glass thermometer. Mercury does not wet the wall of glass tube, which leads to more accurate results. Now let's see the advantages of alcohol in glass thermometer compared to mercury in glass thermometer. Alcohol in glass thermometer is suitable to measure low temperatures because of its freezing point is very low. Alcohol is less toxic than mercury, therefore safety is better. The temperature coefficient of expansion of alcohol is greater and therefore it shows a high sensitivity. The cost of production is less in case of alcohol in glass thermometer compared to mercury in glass thermometer. Now, if we pay attention towards the disadvantages of mercury in glass thermometer compared to alcohol in glass thermometer, those are like this. Mercury is highly toxic for living beings and mercury is not environmental friendly. If mercury spills out, it is difficult to clean because it is highly contaminant liquid. Using a mercury in glass thermometer, very low temperatures cannot be measured because its freezing point is minus 30 degrees of Celsius. The temperature coefficient of expansion of mercury is lower compared to alcohol in glass thermometer. Now, if we look at The disadvantages of alcohol in glass thermometer compared to mercury in glass thermometer, those are as follows. Alcohol in glass thermometer is less durable because alcohol evaporates faster than mercury. Alcohol in glass thermometer cannot measure higher temperatures because the boiling point of alcohol is even below than 100 degrees of Celsius. Alcohol wets the walls of glass tube of the thermometer, therefore it leads to less accurate results.